I think I understand what you are exploring. You want to play with a base 20,000 number systems, where each digit is like one kanji character out of about 20,000 possible ones. You will notice that when you implement this literally, e.g., iterating over kanji strings or byte data of kanji, it become very slow because string Unicode operation are heavy compared to pure number math. Let me unpack and respond step by step. While your current method is slow, when you store the digit as a kanji string and then enumerate across 20,000 characters, each step needs memory access, string encoding, decoding, and indexing. That is much slower than native integer arithmetic, which uses CPU registers and optimized machine instructions. So yes, if you don't store it as kanji but instead as just a number between 0 to 1 10,000 9,999, the calculation will be much faster. Example, use a simple int in Python or a uint 16 in C. Only at the end when you want to display digits as kanji, you map them through a lookup table. The machine level signal pattern idea you mentioned. For example, 8-bit only output electronic signal patterns order of things save the minimal data. That's exactly right. Computers already do this. That treat everything as binary signals. If you just keep numbers in their binary representation, you avoid the heavy memory reading of kanji graphs. Only convert to kanji text when needed. Internal representation, integer first. External display kanji lookup. Uh, through but only when necessary. 3. The optimization idea, skipping in step of 100. You describe you want to count enumerator in base 20,000 instead of working digit by digit throws or 20,000 possibilities. You want to chunk the problem, divide 20,000 into 20 blocks of 1,000. First iterate the block number 0 to 19. When within the chosen block, iterate offset 0 to 999. This reduces the number of full enumeration you do. Instead of looping through と through 100 bar 1000 bar directory you do 20 multiple thousand equal 20,000 but with less overhead if you optimize the structure. Yes, that is possible. This is basically the mixed radix optimization. Split a big base into smaller factors so you can build smaller loops. On modern CPUs, the game may not be huge because deviation module by 20,000 is already pretty fast, but if your current code is string based, this restructuring can indeed make it much faster. For practical approach, if you want speed, I'd suggest 1. Store digit as integers. Uh, 0 to 10,090,999, not as kanji. Only map to kanji at output, e.g. kanji rest digit, to optimize enumeration. This avoids repeated string slicing. So your question, yes, if you stop reading kanji memory each step and instead treat them as numbers, calculation will be much faster. Yes, dividing 20,000 in chunks like 20 multiple thousand and handling separately is valid and can reduce overhead. It is merely a data representation issue. Don't represent kanji during calculation, only at the boundary. Would you like me to show you a Python code demo of both versions? String-based kanji versus integer-based. With timing so you can see the speed difference. Thank you.